Roller coasters have been a source of entertainment for a very long time, but have you ever stopped to wonder why it is that riders are able to stay put in them no matter what direction or speed they go? And no, the answer isn't as simple as seatbelts. It has everything to do with physics. Take a bucket of water, for example. We see that no matter how many times it goes upside down, it stays put in a bucket. But how? And why? Let's experiment to find out. The water staying in the bucket proves there are forces keeping the water in the bucket, which shows a relationship between centripetal acceleration and the period of circular motion.
Acceleration was determined using the centripetal acceleration formula, where A is equal to the centripetal acceleration, T is equal to the period, and R is equal to the radius. So the period, symbolized by T, was determined by taking the average amount of time it took for each revolution. The average came out to be 1.562 seconds. Next, the radius was determined. Her height was 5'7", which is about 1.7 meters. This is roughly the same length as her arm span, so this number was divided by 2 to get the length of her arm, including the clavicle. So this came out to be 0.85 meters. So we would need to divide by 2 again to find the radius of the circle. So divided by 2 is equal to 0.425 meters, which is equal to the radius. Now that we have all the information, we plug those numbers into the equation and solve. And that comes out to be 6.877 meters per second squared.
In order to further prove our theory, let's experiment some more. Here we are using a rotational dynamics apparatus. We used a weight to replicate that of a person on a roller coaster, in which the force applied to the mass can be determined on the rotating plate, which in this case is the popsicle stick. First, we decided to weigh our pennies. We decided to weigh both of them just in case. As you can see, one penny weighed 2 grams, so both of the pennies together weighed 4 grams. Next, we decided to weigh our popsicle stick. As seen, our popsicle stick weighs 9 grams, so the total mass was 13 grams altogether. In order to get a good spin, we had to wrap a string around the wheel and pull. As you can see, pulling with a string got a much faster spin than with our fingers. We wanted to construct a graph with force as a function of the acceleration. Ideally, the slope of the line should equal the mass that is moving, and fortunately for us, that's exactly what worked out as seen in our graph here. So, now we know exactly how roller coasters work. Thanks for watching!